So in chapter 6, I just wanted to talk about two topics here, the concept of association and correlation. And they're often kind of used interchangeably when they really shouldn't be. So let's just take a closer look here. All right, an association refers to or describes this relationship between two variables, right? And in that description of that relationship, we talk about a couple different things. We often talk about the direction, whether that's positive or a negative association. We'll talk about the form, in other words, the shape or the pattern that we see. We often see linear or curved, or again, other shapes. We also refer to the strength, just how closely does it follow any particular pattern or any particular form. And we got some words here: very strong, moderate, kind of weak. And when we also talk about associations, we also kind of want to be on the lookout for any particular outliers. Are there points that are just way out of whack with everything else? So we just kind of want to make note of that as well. All right, so let me give you a little quiz here. So which plot, A or B, has the stronger association? Take a second to think about that. Okay, well, you were probably first drawn to the pattern down here in B because things look nice and close and tightly packed together as opposed to up here in plot A. But if you take a real close look, you probably noticed that the scales are different, and you take a closer look at the patterns, you're going to see that these are the same. So really, they have the same association because it is exactly the same graph. Well, what throws us off here is the scale. Okay? So when I talk about this measure of strength of association, we can be thrown off by the scale. So we really want to make sure that we can kind of remove that or eliminate that from when we're doing our analysis here. And what allows us to do that is a mathematical calculation called correlation. Now, correlation is a measure, so it is a calculation of the strength and the direction of a linear relationship only. So correlation only works with lines or linear relationships. The correlation coefficient, as we refer to it as R, this value R. It's almost the average. And I say almost because we have that n-1, which we've talked about before, product of the z-scores of those values. So what I want to do is I want to take a look at this applet, and I gave you guys a link to this to take a closer look at this concept of correlation and how it relates to the different graphs. So what I'm going to do here is I'm just going to pop 2 points onto my graph here, and you can imagine if I had to draw a linear relationship through these, it would be pretty obvious. I would draw a line right through them, and you can see that my correlation coefficient over here is exactly 1. And if I put another point right on there, almost collinear, I could probably move it a little bit and get it to be perfect. There we go. So I have 3 collinear points. The correlation coefficient, the highest it could be, is +1. Okay. I can do the same thing negative. Okay. Again, negative refers to that direction. And I have a perfectly -1 correlation here. Again, 2 points. I can throw a third one in there, just a little bit off, and we can see we're really close to that -1. If I have a scatter plot with essentially no pattern whatsoever, then I would have a correlation very close to 0. And if I asked you to describe or tell me whether or not there was a linear relationship here, well, I mean, you can draw a line through anything. However, does it really give me a measure? In this case, does it really describe the relationship here, this linear relationship? And well, it doesn't look like it. So we have that correlation really close to 0. All right, now, a couple of things that we need to be careful of with this correlation. Since it's a pretty complicated calculation to put together, and it's always done for us with calculators and software, but we want to make sure that we don't use it as a crutch. It should never be a substitute for looking at the particular graph here. So let's take a look at another situation. Okay, you can see that there is a definitive pattern here. I mean, this goes back to Algebra 1. We can see a parabola here. We could easily write an equation that would give us this. Now, if you take a look at the correlation is really, really low. In other words, it says, hey, I don't see much of a pattern here. But again, it's looking for a linear pattern. So yeah, while I have a very clear definitive pattern here, the correlation is really low. Again, it's looking for that linear pattern. All right. Now, I want to show you about two different situations that have to deal with outliers and why we really need to be careful when we use correlation, because again, we want to look at what's going on with the scatter plot itself, and the presence of outliers can throw us off quite a bit sometimes. So if I give you a little bit of a line equation here, excuse me, some linear data, look, that's almost perfect. Now, I'm going to pop a new piece of data on here. Boom. You could see immediately that the correlation just dropped really far down because of this one particular point out here. If I put this point back up with the pattern, things go back to where they were before. But again, if I take a look at it here, it's such an outlier, all right? It's really throwing off my correlation. Now, if I asked you to use the correlation value, you'd say, wow, that's not really a strong pattern. But if you look at the graph, there's a very strong pattern here, okay? However, it's this one piece of data that's really throwing things off. And if I kind of again remove that piece of data, we're back to where we'd like to be, okay? Nice strong relationship there. All right. So again, got to watch out for outliers. Now, let's take a look at a scenario where an outlier actually makes things look too good. So I'm going to put a bunch of points on here. I don't have much of a correlation at all. You can see over here. Now, I'm going to put another point on here. Boom. So now, this particular outlier is actually making it appear that there's a very strong linear relationship. And you can clearly see that you have this cluster of points down here. There's really nothing going on. But it's this one point that's really far away, this outlier here, okay, that has a lot of control, has a lot of leverage. We call that an influential observation. And, oops, if I kind of move that point, I can grab it, there we go, and bring them back in everybody else, you can see that it's just this one point being way out here that has all this leverage that drags around that particular correlation value, making it look way better than it really is. So if I get rid of that point, we really don't have any relationship there. Okay. So again, always want to look at the graph. Don't just look at the correlation coefficient, because again, the graph tells us much more about the whole story.